Let's take a look at example 5 here together. So in example 5, first thing I want to know, can I reduce that? And if I factor out a 3, I get 3 times x squared minus 1. And so that's x plus 1 over x minus 1, all over x plus 3 minus x minus 3. Nothing reduces, so I can't reduce that. So let's start with my vertical asymptotes. My vertical asymptotes is when my denominator is 0, so x squared equals 9. So I'm going to have a vertical asymptote at x equals plus or minus 3. So I'm going to go to the right 3, make a vertical line, and then to the left 3, 1, 2, 3, we'll make a vertical line there. And now I want to find, let's find my y-intercept. So we want to know when x is 0. So I get 0 minus 3 would be negative 3 over negative 9. So my y-intercept is at 1/3. Let's find, I probably should have looked at my horizontal asymptote first, huh? My horizontal asymptote is, since they have the same degree, y is 3 divided by 1. So y equals 3. So I'm going to make a horizontal asymptote going through 3. Now remember, horizontal asymptote has to do with end behavior. So your graph is going to look different in this section, but it's going to approach the horizontal asymptotes here. So it actually, they don't exist right here, because we can see, here's my point. Now let's look at my x-intercept. My x-intercepts are going to happen when y is 0. So I have 0 equals 3 times x squared minus 1 all over x squared minus 9. So I'll multiply both sides by x squared minus 9, and I get 0, don't I? So 0 equals x squared minus 1, essentially. So x is plus or minus 1. So I have a graph at an x-intercept at positive 1 and negative 1. I'm going to erase that because that looks kind of ugly to see. So I'm going to make this a little bit bigger. So I got an x-intercept at 1 and negative 1. Well, what is going on there? Well, now let's pick some points and let's find the value. So I'm going to make my table now. So I'm going to do x and y, which is 3 times x squared minus 1 all over x squared minus 9. I'm going to do x plus 3, x minus 3 if we wanted to. Now I want to pick a number to the left of negative 3, so I want to pick a negative 4. Well, let's see what happens here. If I put in negative 4 for x, negative 4 squared is 16. 16 minus 1 is 15. 15 times 3 is 45. If I put in negative 4 for x, I get negative 4 squared is 16 minus 9, which is 7. So 45 over 7. So I take 45 divided by 7, and I get about 6.4. So what happens is when I'm to the left 4, I'm going to be up 6.4. So here I am to the left, 6.4. 1, 2, 3, 4, 5, 6, somewhere right about there. So in other words, my graph is going to look like that then, isn't it? Now let's pick negative 2 for x. So if I go negative 2 for x, I get 4 minus 1 is 3, times 3 is 9. All over 2 squared is going to be 4 minus 9 is negative 5. So then I'm going to get negative 1.8, right? So I'm going to be over at negative 1.8. So in other words, I get kind of a parabola thing looking here, don't I? Because it's going to look like this. And then my graph should look like that because my intercepts. Now, did I do the whole thing? Probably I should have done some more points, because then I want to do positive 2 and positive 4, so I get the idea that I do get a parabola. But you do get this parabola right through here because of your middle term there, because you have two asymptotes. We have two vertical asymptotes. So, and once again, let's take a look at this on Desmos. So here's my graph. You have to see it. Okay, that's pretty much what we have. Here's my x or my y-intercept and my two vertical asymptotes, so you can see where the lines, where they cross or they don't cross.